Hello, welcome. You are at the TV station of La Galerie des Solutions during COP21 at Le Bourget. And today we are pleased to introduce Eric Webster. He's the Vice-President and General Manager of Environmental Solutions at Harris Corporation. Hello, Eric.
Hello.
I would like us to tell you a little bit about Harris and what you do here.
Sure, thank you. Harris is a U.S.-based aerospace and defense company. We're about $8 billion with about 23,000 employees. Our environmental solutions business makes ground, air, and space-based measuring instruments for weather and climate capabilities. And we help decision makers and folks with environmental data and information. So we've been building the world's most advanced instruments for about 50 years.
Okay, well, tell us a little bit what you do at COP21 specifically.
Sure. So, as I mentioned, we provide climate and weather satellite and ground and air-based instruments. And our goal here is to help decision makers understand what our capabilities are and how we help provide a complete picture of carbon and greenhouse gases. So we're building an instrument for NASA that measures the sun's radiation and its effects on Earth to understand whether the Earth is actually warming because of greenhouse gases or because of the sun's energy. A space instrument for Japan that measures CO2 and methane, again, to help map the world and its capabilities to better understand where greenhouse gases are. We also have airborne that we've built for NASA that are flying up and down the east coast of the United States, providing researchers and scientists with data about how CO2 moves based on weather patterns. Specifically at COP21, we came to show our new developed product called Greenlight. And Greenlight is a laser-based system which provides a more accurate measurement of CO2 than any other system that we've produced or any other company. It provides customers with a two-dimensional map actually showing where CO2 is on a 24-hour basis. The system's real-time. It's autonomous. You don't need to work with it, right? And it's very easy to use and understand. The map helps to identify exactly where CO2 is and where it's moving based on wind patterns or other things through these direct measurements. In Paris, we've worked closely with the French National Climate Lab, a company called Environmental Earth, local universities, and a company called AER. And what we've done is we've placed 2 lasers on tall buildings here in Paris and 15 reflectors on buildings throughout the city. And the lasers that are eye safe and do not provide any harm measure and shoot to each reflector. And as they're shooting and reflecting, they're measuring the CO2 concentration in the atmosphere. And the computer system and the algorithms take that information and provide that map. And we've color-coded it so you can see when it's at a certain level, it's blue, which would be good, right, or normal. And then it increases to yellows, reds, and greens, right, to show that differentiation, where today you can't get those kinds of measurements at all.
That's very interesting. So, and what has Greenlight observed in Paris specifically then?
Sure. So most folks don't realize, but cities provide about 70% of all greenhouse gases. So understanding the CO2 levels in cities is really critical to understanding climate change and efforts here at COP21. Since Paris is obviously a major city, we expected the average to be slightly above the global average, which is about 400 parts per million. What we found is there's large variations during the day. It's not just 400 or 420. There's actually increases and decreases throughout the day and the night. On average, it's been about 410 to 440 during the day, but during rush hour, because of the traffic and the CO2 from automobiles, it really peaks in the early morning during bad rush hour. It tends to go down in the afternoon and then peak back up slightly smaller during the evening rush hour. So it was something that they kind of expected, but they've never been able to measure the direct CO2 concentrations in that 24-hour period. What was really significant last week is our system measured about 540 parts per million on average throughout Paris for nearly 24 hours. That was very unexpected. And our system, which utilizes wind measurements, noticed that the winds were kind of calm, and in the southwest part of the city, there's some cement factories and incinerators that we think provided more CO2 in the atmosphere. The winds did not move the CO2 out, so the concentration levels stayed pretty high, again, for almost a 24-hour period. So the observations for the researchers and the scientists have been providing a much richer layer of data and information for them to see how CO2 moves throughout the day, and using analytics and other computer algorithms, how those decisions can be used. As an example, if the mayor of Paris wanted to reduce cars on the road, we can measure directly what that impact would be. Does it take it from 440 down to 400? Does it take it from 500 down to 480? So the customers, whether it's a researcher or a scientist or the mayor of Paris, really get unprecedented levels of actionable information. So far everyone's been very pleased, and we hope it'll lead to better decision making as they decide what kind of mitigation and adaptation things to implement.
Okay, and where do you see this technology progressing in the coming years?
Sure. So we envision our green light system and all of our suite of active or laser types technologies are really critical for COP21 in helping to reduce greenhouse gas emissions. They're very important for climate models, right, to have better information to inform climate models. And then again, we want to make sure that decision makers get the best information they can. Our overall goal with our technology is to continue to improve, but also to provide a comprehensive picture using ground, air, and space assets all working together. In addition to the CO2 monitoring we've been doing, we're continue to explore how to measure at a city level. We're able to measure methane from space, actually, using different types of measurements, which we'll be doing for Japan. But we want to do methane on the ground level, which will be important for landfills or other emissions from energy companies and electricity power plants and things. Our main objective, as I mentioned, though, was to get the active or the laser systems to space. No one's done that before, and it would be very transformative. It would provide unprecedented data and capability to allow verification of a national treaty. That's one thing here at COP21, the debates about how do you know that China's reducing its emissions, or France or Bolivia or whatever country. And right now there's no system that can actually measure on a nationwide scale with a level of accuracy how much CO2 or greenhouse gases are being emitted, and then are the mitigation effects actually working. Currently they use a couple of point measurements and mathematical models to create an inventory based on how much energy a nation uses, how much gasoline, how much fossil fuel they're burning. But what the scientists told us, that's not good enough, and that they want a better system that actually measures and verifies what's happening.
Okay. Well, thank you very much for participating in this conference. I'm sure the city of Paris is very appreciative to have this information readily available on CO2 emissions. That's definitely a good thing to have as a tool.
Yes, thank you. We're really glad to be here. The universities and the local researchers and scientists have been great to work with. And, you know, from a Harris perspective, our mission is really to provide the world with better environmental information that really will save lives and property and make a real difference. And we take this role very seriously. And I'm very proud of all the contributions of our employees, our scientists, our researchers, and our technicians. Their efforts really make a difference in the world every day. So thank you very much.
Well, thank you. Thank you. Bye.